All right, let's jump right into this explainer. Today we're taking a look at a centuries-old assumption about the human brain, exploring the blank slate myth, and exactly why our brains actually start out completely full.
You know, if you've ever held a newborn, you've probably wondered to yourself, are they just a completely blank slate? Do we all begin life with entirely empty minds, just waiting for the world to write its story on us? Or is the hardware already kind of pre-programmed? It's that classic battle, right? Genetics versus environment. Well, to figure this out, we're going to look at some absolutely paradigm-shifting research coming out of the Institute of Science and Technology, Austria.
So historically, this whole debate boils down to two competing theories. On one side, you've got tabula rasa, the blank slate. Think of it like a pristine, totally empty sheet of paper. And contrasting that is tabula plena, the full slate. Imagine a page that's already densely scribbled with marks, right? A place where any new information literally has to fight for space, squeeze in, or even overwrite what's already sitting there.
To settle this biological heavyweight bout, researchers led by Professor Peter Jonas zeroed right in on the hippocampus. Now, think of this region as the brain's ultimate filing cabinet, or, its personal hard drive. It's the exact spot responsible for spatial navigation and, this is absolutely crucial, converting your everyday short-term experiences into permanent long-term memories.
When you actually look at the structure of these cells, you see this vibrant, incredibly tangled web. I mean, it kind of looks like a piece of abstract modern art, doesn't it? But actually, these are stained CA3 pyramidal neurons. These are the critical physical cells in the hippocampus that do all the heavy lifting when it comes to storing and retrieving your memories.
And these neurons rely entirely on a superpower we call plasticity. Plasticity is basically just the brain's remarkable ability to adapt. Every single time you learn a new fact or experience something novel, your brain physically alters its structure. It does this by strengthening or weakening connections. But the real mystery for the researchers was, how exactly do these physical connections change from the very moment we take our first breath?
To map out this timeline, the research team actually tracked these neural networks in mouse brains across 3 distinct life stages. We're talking early development right after birth around day 7 or 8, then adolescence a few weeks later, and finally full adulthood at about day 50. They basically wanted a front-row seat to watch this plasticity in action as an entire life unfolds.
To get an unprecedented, really up-close look inside this process, the team had to use a combination of highly advanced methods. They used patch clamp techniques to measure microscopic electrical signals, advanced imaging to watch internal cell activity, and even laser-based methods to activate individual neural connections. They literally mapped out the entire microscopic communication highway between the cells, specifically how the transmitting ends, the presynaptic terminals, hook up with the receiving ends, the dendrites.
So that brings us to the really big question. As the brain takes in more and more experiences, all those new sounds, sights, and smells from early childhood all the way into adulthood, what actually happens to the physical structure of that memory network? If plasticity means the brain changes as it learns, does the network grow denser as you accumulate more knowledge? Or does it somehow shrink over time?
Well, instead of starting as an empty canvas that slowly fills up, they discovered a massive biological plot twist. As Professor Jonas summarizes it, intuitively, one might expect that a network grows and becomes denser over time. But here we see the exact opposite. It follows what they call a pruning model, meaning it starts out completely full and then becomes streamlined and optimized.
So the whole tabula rasa idea? Total myth. The reality is this pruning model. The early neural networks actually start out massively overloaded, completely dense and chaotic. As the brain matures, it acts kind of like a gardener trimming an overgrown bush. It sheds those excess connections to become less crowded, highly organized, and super efficient. You aren't building the network from scratch at all. You're carving it down from a solid block of marble.
Now you've got to ask yourself, why on earth would nature waste all that precious biological energy building millions of connections just to turn around and destroy them later? Why not just build what you need exactly when you need it? Well, the answer lies in an incredible evolutionary advantage: instant memory integration. Think about it like this. If we actually started as a true blank slate with 0 built-in connections, our neurons would have to waste precious time just trying to locate each other to communicate. Imagine you smell smoke and see a fire. Your brain needs to link those instantly so you know to run, right? If the network was totally blank, the process of finding new connections to form that critical memory would be dangerously slow. It would vastly reduce our ability to survive and learn in real time.
And that is the absolute genius of what they call exuberant connectivity.
Starting with a densely packed network means the connections are already sitting right there, just waiting for you to use them. The exact second you experience something, the pathways are ready to instantly link a sight to a sound or a sound to a smell. Once that memory is locked in, the brain just casually snips away the alternate paths that it didn't end up needing.
So this leaves us with a truly fascinating new perspective. If our brains start out deliberately overloaded, packed with these random, exuberant connections just to ensure we can capture everything around us, is this early chaotic web the true secret to how we learn who we are? It turns out learning isn't at all about what we add to a blank slate. It's entirely about what we elegantly carve away that creates our brilliant, unique minds. Thank you so much for joining me for this explainer, and keep exploring the fascinating structures that make you, you.